we're going to continue our Unit 1 review by going over piecewise defined functions. Piecewise defined functions, I know you guys struggled on it a little bit, so just make sure that you really tune in to this video and email me or send me a remind message if you have any further questions. Okay, so we're going to come to number 19. So number 19 is asking us to graph each function. So it wants us to graph this piecewise defined function. So if I'm looking at my function, I know that by the end, I should have 3 pieces. So we're going to focus on our first piece. Our first piece is true for x values less than -3. So our first piece is going to be true over here. So this is where my first piece should go. Okay. So for x less than -3, my function follows 2x plus 5. So let me figure out the first value of my function by plugging in -3. So I have 2 times -3 plus 5, which is -6 plus 5, which is -1. So my first point is -3, comma -1. Now at -3, this piece is not included. So to show that, I'm going to put an open circle at the point -3, -1. 1, 2, 3, -3, -1. Okay. I'm gonna graph one more point before I draw my line. So I'm gonna come to this point over here. So at 2 times -4 plus 5, I get -8 plus 5, which is -3. So at -4, I have a y value of -3. So now I'm going to draw my line. Because there's no piece on the other side of this, I know that my function just keeps going because it doesn't tell me to stop it. So I'm going to draw that arrow to show that it keeps going. So now we have piece 1 done. Okay, we're going to move on to piece 2. So piece 2 is true from -3 to 1. So from -3 to 1, this is the rule that my function follows. So let me figure out what it is at -3. So at -3, my function has a y value of 1. So at -3, my function has a y value of 1. Now, because x is greater than or equal to at -3, I'm going to put a closed circle at this point, because that means that it is included in this piece. It wasn't included in the first piece because there was no equal to sign, but it is, -3 is included in this piece. Okay, I'm going to do one more point. I'll do that at the end point. So I have -1, that's where I get my 1 from. -1 minus 2 which is -3. So at x equal to 1, I have a y value of -3. So at 1, my y value is -3. And I'm putting an open circle because 1 is not included in this piece. And then I'm just going to connect my lines. Okay, so now we have our last piece. For our last piece, this piece holds true for x greater than or equal to 1. So for x greater than or equal to 1. So the first value I'm going to plug in, of course, is 1. So I have 1 minus 3, which is negative 2. So at 1, my function has a point at 1, negative 2. So at 1, negative 2. And I'm going to put a closed circle because 1 is included in this blue piece. 1 is included in this blue piece. And next, I'm just going to pick a random point that is greater than 1. I'm going to pick a point that is greater than or equal to 1. I've already used 1, so let me just find a point that's greater than 1. So I'll choose 3, just for the fun of it. So 3 minus 3 is 0. So at x equal to 3, my y coordinate is 0. And then I'm just going to draw a line through these points. And because there's no stopping piece, I know it keeps going, so I'm going to put my arrow. So on your test, you guys are going to really be expected to, if I give you this part, you should be able to find the graph that matches it. Or if I give you the graph, you should be able to find the function that matches it. Remember, it's all going to be multiple choice. Okay, so this is me going the other way. What rule defines the function in the following graph? Right off the bat, I can see that I have 3 distinct pieces in this piecewise function. I have this piece in blue. I actually use my highlighter. I have this piece. I have this piece. And I have this piece. Okay. So I know that for my piecewise function, I have 3 pieces. So I'm going to look at my first piece that is in yellow. So for my first piece, it looks like I have a domain of -3 to, because of this arrow, looks like it keeps going on to infinity. So from -3 to infinity. So my domain for this piece, my first piece, is x is greater than -3. And the reason that I say it's greater than -3 and not greater than or equal to -3 is because I have an open circle at -3. So that tells me that it is not included. All right. And now I just have to find the equation for this line. Okay. So to figure this out, I can look at this and determine my slope. So remember that your slope is rise over run. So it looks like my slope, I'm going up 1, 2, 3. So I have a rise of 3. And I'm going to the left 2, because that'll get me from this point to this point. So I'm going over a run of 2. And now because my graph is decreasing, meaning that I can look at this line and see that it has a negative slope because it's going down, I know that my slope is -3/2. Okay, but I'm not done yet. So I know that my slope is -3/2. However, just knowing the slope isn't enough to tell you the equation of the line. So to determine the equation of this line, I'm going to use my slope-intercept form, y equals mx plus b. So I have y. I know that my slope is -3/2 x plus b. And so my goal is to figure out this b. What is my y-intercept? Because I can't look on the graph and tell what it is. If I could, we'd be done a lot quicker. So I can't look at my graph and tell what it is. Okay. So in order to figure this out, I'm going to pick a random point on my line. So I'll pick this point. This point has an x coordinate of -5 and a y coordinate of 0. -5 will be my x, 0 will be my y, and I'll just plug these values in. So I have 0 equals -3/2 times -5 plus b. And now if I solve for b, I should get b is equal to -15/2. Okay. So now that I know what b is, I can give you my equation of my line. So my line has an equation of -3/2 x minus 15/2. And this is just me putting my slope and my y-intercept and letting that define my line. Okay, so we'll go to the next one. The next one we got really lucky because our y-intercept is included, so we can see what our y-intercept is. So we don't really have to go through the struggle of doing all of what we did before. Okay, so the first thing I do want to figure out is my slope. Remember, my slope is rise over run. So I have a slope of 1 over 5. 1 over 5. And I'm picking the points that I use to find the slope because those points lie perfectly on a coordinate point. Like I'm not using, like we can clearly tell that this is 2, 2. I wouldn't use this point because I'd be like, okay, is that 1, I don't know, 1.75? Like I wouldn't use that point. I'm just going to use clear coordinate points to determine my slope. Now, for the sake of time, we're going to make a guesstimate on this y-intercept. This looks like it's about 1.7. So I have my next piece is 1 over 5x, because that's my slope, plus my y-intercept, which is 1.7. And the domain of this piece is from -3 to +2. -3x, +2. So it looks like -3 is included because there's a closed circle in -3. And I know that 2 is included because there is a closed circle at 2. Now for my last piece, I got really, really lucky because this is just a horizontal line. Horizontal lines do not have a slope. The slope is 0 right here. It doesn't rise, it doesn't run, the slope is 0. And if I keep extending it, I know that the y-intercept of this line would be 3. So the equation for this piece is just 3 because there's no slope. If you need to see it, it's y equals mx plus b. If I know that my slope is 0, and I know that my y-intercept is just going to be 3, this is just going to go away, and it just leaves me with 3, not negative 3, just 3. And then I just need to get the domain of this piece. This piece ranges from 2 to 5, where 2 is not included, but 5 is included. And that's it. So on your test, you're going to be expected to, if I give you the function, find the graph, or if I give you the graph, find the function. And it'll be all multiple choice. So you just make sure that you know how to figure that out.